Hello, folks. Welcome. Thank you so much for being here. I'm really excited to have you. And there is a lot of weather going on, so we should probably just go ahead and get started. So, just a quick introduction of myself. So, I am Dr. Hansi Singh. I'm founder of Planet AI. I'm an Earth system scientist. I've also worked within academia. I've worked within the US Department of Energy, and I still have a foot in science. I am still participating in some Earth system model development over at NCAR. And specifically, the reason why, Planet is here and why we're probably all here is that what we study in research, specifically on the Earth system, has impacts on the real world. And these impacts are sometimes extremely substantial. And so our goal at Planet is to really help folks get a handle on these impacts to build climate resilience for their businesses. So, what we're going to be going over today is the long range weather outlook. And this is the outlook for the next 6 months. And so, we're going to be covering Q3 and Q4 of this year. Just briefly, we're going to be speaking about how long range weather forecasting works. And then we're going to be talking about the fundamentals. Pretty much this entire webinar is going to be devoted to this growing and strengthening El Nino over the tropical Pacific and its impacts around the world. My guess is that this is why we've gotten a lot of interest in this webinar. And so I hope that as we review these impacts, that this is useful to you. Please note, this is going to feel really like a fire hose of information. So yeah, hang on tight. There will be a recording. And if there are specific areas that you are interested in, please let us know. We would always be happy to spend a little time with you to go over the forecast because we're living in somewhat unprecedented times, as I will show. So, to begin, how does long range weather forecasting work? The way that it works is through a different modeling system than how we do our conventional 10 or 14-day weather, like what you have on your phone. So, a 10 or 14-day weather model is essentially an atmospheric model. It's a very complex model, but it only models processes in the atmosphere. The atmosphere is very mercurial and forgetful. Generally, it has a memory of about 2 weeks. This is why we don't really have any atmospheric driven predictability beyond approximately 2 weeks. When it comes to anything beyond 2 weeks, we really need a much more complex modeling framework. This is where Earth system modeling comes in, and these models are much larger and more comprehensive. In addition to comprehensively modeling the atmosphere, they also include ocean, land, and ice components. The ocean component in particular is really essential for long-range forecasting. So the ocean has months to years to centuries to millennia worth of memory, depending on, where you are in the water column, et cetera. And so, really helps us break that predictability barrier compared to what is possible through a conventional weather model. Note, we cannot tell you day-to-day fluctuations with this kind of modeling beyond 14 days, but what we can tell you is we can look at weeks, we can look at months, we can even look at seasons, and we can tell you what to expect in terms of anomalies, deviations from normal over those particular time horizons. Now, let's get started on the forecast. The fundamentals here are literally El Nino. So usually when I start these types of webinars where we're going over the forecast, I talk about all these different modes of variability. Usually I include NAO in here. There's a lot of fun, little things to talk about. But right now, the biggest story in the house is El Nino. And so this is what we're going to be focusing on. Right now, the phase of the QBO doesn't really matter because in the Northern Hemisphere, at least, we don't really have much of a polar vortex or any polar vortex, in fact, because we're in summer. And then, the MJO, its teleconnections tend to be weak. For folks that are in South Asia, you might see a little blip of MJO based precipitation in the next few weeks, which is probably good because that region is very dry thanks to the El Nino. But in general, El Nino is the major story right now. And so this is what we will be focusing on. So the big story right now is that everybody has declared that El Nino is officially here. When El Nino is officially here, it just means that the temperature anomaly in the tropical Pacific Ocean has now exceeded zero point 0.5 degrees Celsius. So it means that the tropical Pacific Ocean, which literally is half our planet, is spitting out heat into the atmosphere. It's storing an enormous amount of heat. That heat is coming into the atmosphere, and that heat is then driving weather patterns. We have an entire webinar all about El Nino. At the very end, I will link to this particular webinar that covers the details of El Nino. But just because this is the focus today, a really quick rundown. El Nino, it's a major mode of variability in the Earth system. It operates on planetary scales. It is enormous. The Pacific Ocean is about half our planet, and El Nino stretches out about 5,000 miles across the tropical Pacific and has an enormous amount of heat that it then releases. That heat that it's releasing then drives global weather patterns through teleconnections, which are essentially actions from afar in the Earth system that, are not magic. They're literally just waves that form in the atmosphere that then move that energy around. And so this is why El Nino is so consequential because it is enormous and it drives global weather patterns in its enormity. So another very important thing about El Nino, so here we're looking at two previous El Ninos, the 1997 El Nino, the 2015 El Nino. Both of these were super El Ninos. This phenomena is so predictable. So the signal is extremely strong in terms of its impacts around the world, and it is extraordinarily predictable, 6 months into the future and even beyond. And so, because of its predictability, even though it's going to have impacts on weather around the globe, as I will show you, none of these impacts necessarily need to come as a surprise. They are very predictable. These impacts, they do affect industries. So these industries include insurance, agriculture, energy, utilities, mining and natural resources, construction, logistics, etc. What are some of the ways that El Nino impacts industries? So it's really a mixed bag. It depends on where you are in the world. So specifically, many of the impacts of El Nino are linked to the fact that it is quite dry. Many regions of the world during an El Nino event suffer from droughts. And so this means that there's less hydropower, less water for agriculture. Transportation in many parts of the world relies on rivers, so there's limitations to this transportation, which then impact supply chains. There's also a lot less water available for heavy industry because whatever water there is, everybody is fighting over it. And the lack of water, in addition to high temperatures, can increase the risk of wildfires. Temperatures are high. Often we see a lot of summer grid demand during El Nino years, though it depends on where you are. It's actually very regionally dependent, so that's quite important. And in some regions, we don't deal with drought. We actually deal with the opposite. We deal with deluges. And so El Nino tends to be linked to flooding and landslides. And all of this taken together leads to shifting patterns of insured losses. So usually El Nino years are accompanied by higher losses for insurers, but that is very, very, very regionally dependent and hazard dependent. So we will go through some of those as we look at the impacts of this coming El Nino. So why does El Nino have so many mixed implications for precipitation? A lot of this has to do with what El Nino does to the atmospheric circulation near the tropics, specifically these cells called the Hadley cells. So the Hadley cells, they sit right near the equator. They essentially are bringing warm, moist air to the equator. They create a ton of deep convective rain, thunderstorms over the equator near the equator. This region is called the Intertropical Convergence Zone. And then they bring drier air way up high in the atmosphere into the subtropics. So they are what create the subtropical deserts. This is why some regions on our planet are very dry, like the Sahara. So when we have an El Nino, what happens is that these Hadley cells, they get stronger and they contract towards the equator. When they contract towards the equator, the subtropical jet stream also tends to move towards the equator. So we have these dry regions. So wet region right near the equator, that is more intense, more dry regions, and then jet streams that are then shifted a little bit further towards the equator. And these are the extratropical jet streams as well. And so what this means is that you get this mixed response. Some regions are drier than usual, specifically the subtropics, and other regions are specifically wetter than usual. Some regions in the deep tropics, as well as regions where the jet stream is shifting to. Okay, let's look at the Nino 3.4 index. So the purple line here shows our forecast of the Nino 3.4 index. The red line is the ECMWF CEAS5 forecast. You can see that we're a little bit less extreme than ECMWF CEAS5. Here we're moving forward month by month all the way to December 2026. And what you see is something that is frankly record breaking, at least from the observational record. So in the observational record, we have never had a El Nino event exceed 3. And it looks like, we're very likely to hit that threshold of 3 or be above it. And so what that means is that this is just an extremely strong event that we are going to be experiencing over the next year. And the teleconnections, the impacts of this event are also going to be very strong. So here, just to put this in context, this is the El Nino index, the Nino 3.4, as well as the relative Nino 3.4. It's just calculated slightly differently over the last 45 years or so. And so what you see here specifically is that, here's our forecast right here. So about 3.2, hitting 3.2. So this is this red dotted line. And this is where we expect to hit. And you can see that in the past, at least when we've been keeping good records, we have never seen an event get to this level. So this is a really strong event. Even if we were to use this relative index, it would still be on the order of, one of these major events that we have had last century. So for most of us, this is going to be, something that, well, for all of us, pretty much, this is going to be something like that we've never actually experienced before. We are living in record-breaking times. It is really important right now just to say, please do not panic. It is okay. We will get through this, but it is record-breaking. Very likely to be record-breaking. So one way that El Niños tend to drive record-breaking impacts is through their effects on global temperature. So generally speaking, during El Niño years, shown in these red colors here on the global temperature record, these years tend to be record-breaking. They tend to shatter global temperature records. And so really, in this case, we expect 26 and 27 to be on par with these previous extreme events. We have a warming globe, and whenever we get an El Nino, we sort of get this little like step function increase in temperatures. And this is just because it is the ocean that is releasing a ton of heat to the atmosphere. And this is warming our planet, and many areas of our planet will be warmer over this coming year, thanks to this El Nino. So here's a view of our forecasting platform, which sort of shows some of these impacts coming towards year end. And you can see that huge continental areas are going to be significantly warmer than usual. So this includes South America, Australia and Oceania, much of Africa, South and Southeast Asia. Yeah, it is going to be a warm time. And in fact, it also includes the Arctic. The Arctic looks like it's going to be quite warm this coming winter. So major global impacts. Note, however, this is not global necessarily, right? Because there are areas that are cool. So it's really important to keep in mind that the effects are regional, but there are some areas where we really see these continental scale warmer than usual temperatures, specifically these continental regions. An additional player to really keep in mind this coming year with this El Nino is the blob 2.0. So the blob is this marine heat wave that is formed off of California and Baja California, and we expect will impact fisheries, aquaculture systems, and marine ecosystems throughout this region. The last time we had a major blob, it was a little bit further northward. It was during or right before that previous El Nino from 2015 to 2016. And we had massive die-offs of shorebirds due to collapse of fisheries. So, this is definitely something to keep in mind in terms of vulnerability of fisheries and ecosystems in this location. Let's look at the hurricane season now. So there's a lot of panicking about El Nino and extreme weather. Well, one thing that we can say is generally speaking, El Ninos are associated with a mild Atlantic hurricane season. Now, there are some caveats here. So first of all, we tend to see fewer hurricanes form over the Atlantic. And these cooler or this is due to the fact that sea surface temperatures tend to be cooler over this region. We tend to have greater wind shear, so it is harder to form these types of convective systems, these tropical depressions that lead to hurricanes. However, note that this doesn't mean that we're going to get zero hurricanes. It does not also mean that, we maybe are going to get very weak hurricanes. There could still be a major hurricane or two. It's just that we expect the total amount of cyclogenesis to be significantly less. For the Pacific, we have a little bit more of a nuanced story. Some parts of the Pacific are regions where we expect greater cyclogenesis. And in particular, during El Nino years, we generally see greater landfall over Japan and Korea for hurricanes, though we also tend to see less landfall over China, over the Philippines, and over some of these regions in Southeast Asia. So it is a bit of a mixed bag here, but specifically in Korea and Japan, this is impact of El Nino to really be aware of, where the amount of cyclogenesis over some parts of the Pacific could lead to more typhoon activity for this region. So now we get into some of the drying impacts of El Nino. One of the major impacts of El Nino is a weak South Asian monsoon. We expect this monsoon this year to be shorter and weaker than usual. The monsoon has already shown up a bit later than usual, though, there's a lot of interannual variability there. We don't really know, is that El Nino or is that just interannual variability? Not totally clear about that, but the fact is as this El Nino strengthens, we are going to see more and more drying over South Asia. And this literally has to do with the fact that the tropical circulation has shifted so that all of the convection is over the tropical Pacific or the central and east tropical Pacific. And so we get these large dry regions, and this includes South Asia. And so what this means also is that temperatures are going to be pretty elevated this summer. Note also there is an interesting possible MJO impact that we're seeing over the next few weeks, where we might see some extra precipitation to start off the monsoon. So we are keeping a look at that. I would put that at about 50-50 right now in terms of how much of that rainfall we're seeing. But generally speaking, this is going to be a weak and short monsoon season. Um, Temperatures will be elevated. We're going to have less water, specifically for agriculture, hydropower, heavy industries in general. So definitely something to watch out for. Many of the impacts of El Nino for South Asia are specifically linked to this drying that is due to reduced monsoonal rainfall. Note, however, if we're super worried about hydropower, for example, and energy demand over this region, just keep in mind that it's not totally gloom and doom, because we do see some evidence for this region of both for South Asia as well as Southeast Asia of greater wind and solar resource availability. So these purple colors here mean more wind, and these orange colors here mean more solar energy. So, maybe this is also a little bit of silver lining to, I think, what is going to be a challenge in terms of water resources over the coming 6 months to year. Getting to Southeast Asia, this region is also going to be much drier than usual. And so once again, this is due to shifts in the tropical circulation, namely that most of the convection is sitting over the central Pacific and it is not making it out to the West Pacific. And so what does this mean impact-wise? It means that there will just be less water for agriculture, both commercial and subsistence. The major crops that we may see impacts in are palms, specifically for palm oil, as well as for rice, which is a pretty essential staple. And in addition, we will see water resource limitations potentially for mining as well as for river transportation, since this is a part of the world where a lot of the transportation occurs through rivers. This then brings us to wildfire risk. We've talked about how El Nino dries many parts of the world. And so in many parts of the world, this is associated with a higher risk of wildfires. So this includes the American Pacific Northwest, or the North American Pacific Northwest, the Southeast Asia, Australia, as well as the Amazon. So what this means is that prolonged drier than usual conditions can increase the amount of flammable fuels, in other words, dry vegetation available. And so when there are instigating events, say somebody is just trying to do, clear away some agricultural land, it is very easy for that to get out of control when you have a ton of dry vegetation sitting around. And so we do see a risk of major wildfires during these El Nino years. Continuing with our story about drying, let's take a look at Africa, where there are just major impacts evident in Central Africa. So I'm showing the forecast, particularly, this is for August 2026. You can see there's this dry region shown in yellow and this wetter than usual region shown in green. And so this dry region is specifically the Sahel, which is already a region that is quite dry. There's a lot of subsistence agriculture here, and it is very much on the edge in the sense that it is right near the Sahara. And so, it is prone to droughts. And so, unfortunately, this region will be getting drier this year. And, interestingly, this is not a usual El Nino signal, though we have seen it before. There is some evidence that the Gold Coast region, which is already very lush, will get more precipitation than usual. And so, what is this sort of mixed forecast going to impact? In particular, we may see impacts for cocoa. If this excess precipitation becomes too extreme, we may actually see some increase in disease and other types of pestilence for the cocoa farms that are in a lot of the Gold Coast. We might see some mining impacts as well over this Gold Coast. And specifically for the Sahel region, it is very likely that subsistence and subsistence agriculture and any commercial agriculture, I don't think there's actually any commercial agriculture in this region. So subsistence agriculture will be impacted. So, we may see some areas where humanitarian aid is really necessary for this region. Now, once again, we talked about El Nino, how El Nino is a really mixed bag. And for East Africa, we really expect some extreme precipitation, heavy precipitation. So this is the forecast for end of year, October, November, December, Q4. And you can just see this huge amount of excess precipitation expected over East Africa, including Ethiopia, Somalia, Kenya, and Tanzania. And so the last time we had a super El Nino, if you check out the news, there was just so many reports of flooding and just extreme rainfall. So this is an image from 2023 in Kenya. And so where do we expect impacts specifically for commercial agriculture as well as subsistence? And then, of course, for public health and public safety. Obviously, flooding is bad for public safety. The public health angle is particularly linked to the fact that when you have excess precipitation, often this tends to flood sanitation systems as well. And so you tend to get cholera outbreaks as well as huge malaria outbreaks because the mosquitoes are very happy with all of this excess rainfall. Now, let's move to a different part of the world where now instead of excess rainfall, we're going to see a pretty strong drying signal. This is over Central America. Over Central America, we expect much less rainfall than usual. And this is a region that generally tends to be very drought vulnerable. And this will almost certainly have impacts over the coming months on shipping through the Panama Canal. So once again, this is a region where there is a ton of agriculture and mining, as well as essential global shipping, and water resource limitations are going to impact all of those industries. So in particular, the Panama Canal has already preemptively issued weight restrictions for cargo vessels starting in July. So we are already going to be on track for reduced through fare in terms of dry bulk weight through this region. So definitely something to keep an eye on when it comes to trade, global trade. And I'm almost done. So, as I said, this is a fire hose. Once again, happy to chat with any of y'all if you want to go over specific regions. Just really quick to touch base on South America, where we're seeing some interesting trends, specifically some areas where we expect much drier than usual conditions, including the Amazon, Venezuela, and Colombia. And then regions where we expect more rainfall, and that includes southern Brazil. And this particularly is the region of Rio Grande do Sul. And following the last El Nino, you might have seen this iconic horse named, I think, Caramelo, who was caught on a roof because he was in a flooded area. And thankfully, he was saved. But this was a pretty traumatic time for this entire province. And so this is an area to really keep an eye on because they're going to start to see a lot of excess precipitation in Q4 this year, and it is likely that it will continue early next year. And if we see any major events, we may get a replay of what we saw in 2024. Obviously, this is all, not for certain, but this is a possibility. Finally, just to say, you might be wondering about what to expect this winter, or sorry, this Q4, for some for North America and Europe. And what we see here is specifically over South and Southeast US, as well as Mexico, as well as Western and Southern Europe. We're going to see excess rainfall. This tends to be, at least this tends to be what we see during El Nino years. And often this is linked to public safety issues because it's very easy for excess rainfall to, sometimes turn into torrential rainfall. And then you get issues with floods and landslides. So during El Nino years, we do tend to see a lot of flooding in this region in particular, over in the Americas. So something definitely to keep in mind. So we've run over time. There's just a fire hose of information, and I've sort of just scratched the surface here. So there's a lot more to say. And so, because there's a lot more to say, what we're going to do is over the next few weeks, I am going to have some webinars where we focus on very particular regions. So, our next webinar will specifically focus on the Asia Pacific outlook. And if you want to learn more about El Nino as well as other weather phenomena, please find us on our YouTube channel linked here with this QR code. And we specifically have a webinar that is on El Nino. So thank you so much. And when I say it's all El Nino, it's on the science of El Nino. So it's generally on El Nino rather than a fire hose of what to expect over the next 6 months. So that might be a good primer if you're interested in sort of where all of these impacts come from, how we understand them, etc. Thank you so much. If you want to talk about weather, you know where to find us. And until next time, thank you for being here. Take good care.